right, so I just started the recording. So today we are talking about linear inequalities and graphing those inequalities. So linear inequalities with graphs. So we're going to do 2-word problems, and then we're going to do about 4 graph examples. And then the assignment for today is sort of challenging, so definitely take some good notes for this part. All right, so first, we're going to kind of review writing linear equations from last class, because I know that was somewhat of a challenge. So being able to read the problem and match it with an equation. Okay, so let's go ahead and start. If you feel like you know the answer, you can private chat me what you think it is. Airline passengers pay $439 to fly. So this is how much they pay to fly, period. So they pay this one time to fly to California. For this price, customers may check 2 pieces of luggage. 2 pieces of luggage. So they get to check in 2 pieces of luggage for this price. There is a fee of $25 for each additional piece of luggage a passenger wants to check. Which function can you use to find the amount in dollars the passenger has to pay to fly with P pieces of luggage where P is greater than 2? So let's kind of break this down. They pay to get on the flight, you pay a one-time fee of $439. Automatically, if this is one-time fee, I know this is talking about the y-intercept automatically. So I'm going to write that to the side. You get 2 pieces of luggage free. So you already get 2 pieces of luggage for free. That's important information. And then $25 for each additional piece of luggage. $25 each additional piece of luggage. Well, this each word tells me this is talking about the slope. So we're trying to find an equation that's telling me I pay $25 for each luggage after I already have my 2 pieces free, and then $439 for the ticket in general. In the classroom, can y'all take about 30 seconds and discuss this? Which one do y'all think the equation is and why? And I don't want to just hear Alexa. Discuss, discuss, discuss.
I'm thinking, y'all.
Sure it's B, but I could be wrong. So.
All right.
Miss Patterson, what do you think, Sophia?
So I like the conversation going just now. Good job, guys. So good. At least we all agree that $439 is a one-time fee. Okay, and then from there we need to see. Okay, well, which expression shows me that I would be paying $25 for each luggage, but I have to take away those first 2 luggages for free out of there. C and D automatically don't make sense, because why would I divide by 25, right? What does that mean, dividing by 25? That means I would take any piece of luggage and divide it by 25. So if I have 3 pieces of luggage divided by 25 plus $439, that's what I would be paying. So C and D together don't make sense. So I wouldn't be dividing by 25. A is saying 25 times every piece of luggage plus $439. So is that telling me I get the 2 pieces of luggage for free?
No.
No, right? That says I'm paying for, this says I pay for each piece of luggage. So this right here is telling me I pay $25 for every piece of luggage minus the 2 that come for free, plus the $439 it costs to fly to California, period. So B would be my answer.
Yay.
Good job. I think y'all as a class came to that conclusion. All right, let's look at the ordering a flower arrangement. She can choose any combination of roses. and carnations for her flower arrangement. And she does not want to spend more than $30. She does not want to spend, excuse me, excuse me, does not want to spend more than, gosh, thank you. Okay, does not want to spend more than $30. If roses cost $3 each, and carnations cost $2 each, which inequality represents all possible combinations of X roses, oh my gosh, X roses and Y carnations? Excuse me, I hope you understood everything I just said. Okay, so she's ordering a flower arrangement of roses and carnations. It already said roses represents X and carnations represent Y. So carnations plus roses. Roses plus carnations. If roses cost $3 each, well, roses cost $3 each, the 3 is going to go with the X. 3X. That means I paid $3 per rose. And carnations cost $2 each, 2Y. That would be $2 per rose. Which inequality best represents the combination of X roses and Y carnations? So we know that it's going to look something like this. 3X plus 2Y, some kind of inequality, 30. I want y'all to discuss what inequality should go in here if she does not want to spend more than $30. She does not want to spend more than $30.
Alexa, which one's the less than to them?
Less than is this.
So here's less than, and here's greater than.
I got it. I think it's A, because A comes from me.
Okay, I think it's B because it says she doesn't want to spend more than $30, so she can spend $30. So it can be equal to $30, or it can be less. So I think it's B.
I think it's B too.
Okay, great job, class. So 3X plus 2Y is less than or equal to 30 because she doesn't mind spending $30. She just don't want to spend more than $30. So she's willing to spend less than or equal to $30. So this would be the answer. Good job. And notice C and D automatically can cross out because they're saying $2 per rose, which is not. So they had the coefficients incorrectly. Good job. So this is saying she only will spend less than 30, not equal to 30. Okay, awesome. So now we're ready to look at inequalities, okay? There's a couple of rules we need to know when graphing inequalities. I do not suggest that you write every single word down because that would take way too long for notes. But I do suggest you write down some symbols in your notes. Okay. If there's a less than symbol in an inequality, the less than symbol tells me I'm going to have a dashed line. The less than symbol will tell me I will have a dashed line and I'm shading below the line. So this is how I would write it, just so I don't have to write every single word. But you can definitely write every single word if you want to, but you just got to keep up. So the less than symbol tells me I'm gonna have a dashed line. So my graph is gonna have a dashed line and I'm gonna be shading below the line. So for example, this would be my graph. My line would be dashed because it's less than, it's not equal to, and I would be shading below the line. So it looks something like that. Greater than, a greater than symbol, if there's a greater than symbol, is going to be a dashed line, but then I'm shading above the graph. So same thing, except I'm shading above the graph. So if I had a graph, it would have a dashed line, but I would be shading above. It is imperative that you actually understand and learn this because they took off the feature on Desmos when in star mode, it won't let you graph inequalities anymore. So you have to know how to graph inequalities. The third bullet point, if it's less than or equal to, the only difference is it's going to be a solid line with shading below the line. So if it's less than or equal to, my line is just going to be solid, but I'm still shading below. If it's greater than or equal to, same thing again. It's a solid line because it's equal to, and I'm shading above the graph line. If it's a vertical line and it's greater than, you're going to shade to the right. If it's less than, you're shading to the left. So if my line was straight vertical, this is the right-hand side, this is the left-hand side. So depending on where you're shading, depends on the inequality that is being used. Again, the same rule applies. If it's equal to, it would be solid. If it was not equal to, it would be dashed. A horizontal line, greater than, shades above the graph, and less than shades below the graph. So if my line was horizontal, it'd be either above or below. So what we're going to do is we're going to do a couple of graphing examples. What I would do is screenshot this page because you're going to need this for the assignment. All right, let's look at our first graph. Again, I suggest that you take notes regardless. Either you're taking a screenshot and you're graphing it in your photos, editing it in your photos, or if you're on notebook paper, make sure you're doing a pretty legit job, especially writing down the equations. Either way, the equations are the big thing here, and understanding what the equation is saying. So this equation is in slope-intercept form. That's y equals mx plus b form. What I want you to do, anytime you see an inequality, is I want you to totally annotate this equation. First thing you should see is, what kind of symbol is this? The greater than symbol. So automatically, I'm going to point that out. It's a greater than symbol. It's greater than. So that tells me, and it's not equal to, this tells me it's going to be a dashed line. And I'm shading above. This tells me it's going to be a dashed line, and I'm shading above. Since this is in slope-intercept form, I don't have to do any work on the equation. I know my slope is 2, or 2/1 for our graphing purposes. And I know the y-intercept is -4. So when I graph this, I'm going to first plot the -4 y-intercept. So there's my -4 y-intercept. Then this is a positive 2/1 slope. That tells me to go up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. So rising 2, running 1. Now, before I just draw a line through this, I got to pause and think. This is a greater than inequality, so this is going to be a dashed line. So it will be a dashed line through these points. And I should probably just keep going so that this looks better. And then this greater than symbol tells me to shade above. So I'm going to be shading above my line. So that is what my graph will look like. So this is all we're learning today, but it is very difficult when it comes to understanding the shading part and remembering the shading part. On Canvas, I posted a really good video that explains really the why behind all of this. So this is everything greater than 2x minus 4. So this shaded region is called the solution to this graph. So here's where you're going to get your questions, right? You're not going to be asked to graph this. There's no way you could grade somebody graphing this, unless we were all in person and I could grade it. But I'm talking about the STAR test. How they're going to ask a question is they're going to ask, is an ordered pair in the solution set? So for example, is 0, 5 in the solution set? What it's asking, well, let me go graph 0, 5 or plot that. 0, 5 is right here. It's asking, is 0, 5 in the shaded region? Well, yes, it is in the shaded region. So yes, it is a part of the solution set. So what if it asked, is 0, negative 4 in the solution set? Well, let's go plot 0, negative 4. Talk about it amongst yourself. Do you think this is part of the solution? 0, negative 4. And why?
No, because it's on the line it's less than. Yeah, she's right. It's not greater than or less than or equal to.
We're thinking no.
Wow, I'm blown away. Y'all's explanation was absolutely perfect. This 0, negative 4 is on the dashed line. And this dashed line is not equal to, therefore it's not in the solution set. Good job, guys. Good job. Perfect. So because this line is dashed, it's not an equal to line, it is not in the solution set. If it was equal to, and this was a solid line, it would be in the solution set. So good. So no, it's not in the solution set. Wow. Good job. Go Sophia. All right. Let's look at this one. 4x plus 8y is greater than or equal to 12. With linear inequalities, always change it to y equals. And hopefully I have an example in here of y. Let me look real quick. Yeah, I do. Okay. So before we even break this down, we're going to change this to y equals. So we want to isolate the y. So I'm going to rewrite it down here. So 4x plus 8y is greater than or equal to 12. So I want to change this to slope-intercept form. So to do that, I got to get rid of this positive 4x. So I'm going to subtract 4x from both sides. Did someone say something?
Yeah, it's not important anymore.
Oh, okay. Are you sure?
Yep.
Okay. So I'm going to bring down the 8y greater than or equal to 12 minus 4x. Then I got to get rid of this 8 that is multiplied to the y. So I'm going to divide both sides by 8. That'll give me y is greater than or equal to 12 divided by 8. I do not know why I wrote this decimal for this. 12 divided by 8 is 1.5. And then negative 4 over 8 is negative 1/2 x. Okay, so this is telling me the greater than or equal to sign is telling me, one, I should have a solid line. And the greater than symbol tells me to shade above. Now, I do not want 1.5, a point of 1.5. That would mess up my graph quite a bit if I started at the 1.5. So we're going to start somewhere else. So let's see. If I plug in the point 1 for x, 1.5 minus 1/2 is 1. So that means the point 1, 1 is on the graph. So we're going to plot that point first. 1, 1. Oh, my eyes burn so bad. Sorry, give me 1 second. Let me pause my recording. The reason why I'm plotting the point 1, 1 is because 1.5, if I put 1.5 on the y-intercept, it's going to be hard to accurately graph my slope. So I'd rather use a legit whole number point. So I plugged in 1 for x. 1/2 times 1 is 1/2, and 1.5 minus 1/2 is 1. So the y value would be 1 at that point. So that's why I plotted that point. From here, we're going to use the slope. So the slope, the rise over run, is 1 over 2, and it's negative. So this time I'm going to go down 1 and run 2. Down 1 and run 2. Down 1 and run 2. So I can just keep going with this pattern. So this is a slope of negative 1/2. And my line is solid, so I'm going to put a solid line through here. And I'm shading above. I'm shading above. So if I'm on top of this line, this would be the shading above. Pretend my shading is just absolutely wonderful. So here's my question, class. Is the point 2, 3 in the solution? What do y'all think?
Yes.
Yes. If I go plot the point 2, 3, bam, it's right here in the shaded region. So this is part of the solution. Is the point -5, -1 in the solution?
No.
No. Because -5, -1 is not even in the shaded region area. Okay, so just to reiterate what we were saying earlier, let's say I was asking about the point 1, 2, 3, 0. This is in the solution because it's on the solid line. So 3, 0 would be a part of the solution. Oh. Any questions? Or is this seeming, are we seeming to understand pretty okay? All right, take your silence as a yes. Okay, let's look at this one. 2x minus 4y is greater than or equal to -4. Automatically, some of y'all are thinking, oh, I'm gonna shade above because it's greater than or equal to. Remember what I said, always change standard form into slope-intercept form. So 2x minus 4y is greater than or equal to -4. So let's change this to slope-intercept form. First, if you get rid of the 2x, it's positive 2x, so I'm going to subtract 2x from both sides. Please, please, please have this in your note. So when I subtract 2x, it gives me -4y is greater than or equal to -4 minus 2x. And then I got to divide by this -4. Hold up, hold up, hold up, hold up. Does anyone remember when I divide by a negative, does anybody remember what happens to the inequality sign?
Split.
It flips. So when I divide by this negative, it's going to be y is less than or equal to -4 divided by -4 is 1. -2 divided by -4 is positive 1/2 x. So look what happened. This flipped on us. So we can't just look at this and be like, oh, it's greater than or shading above. We got to make sure we change it in the slope-intercept form so we know for sure. So this is actually going to be a solid line, because it's equal to, but we're actually shading below. So plot my point at 1. My y-intercept is 1, so plot my y-intercept. My slope is 1/2, so it goes up 1 over 2. Up 1 over 2 is positive, so that's why I'm going up and to the right. Make it a solid line. And then I'm going to shade below my line. Questions? Questions? No? All right. So write this equation down. 2x is less than y plus 3. Say what? This doesn't look familiar. It's kind of confusing now. Come on, Miss Patterson. All right. What have we been doing to each equation? What do we want it to say? Like which variable do we want isolated?
Y.
The y. So right now this is not what we want. We want it to say y. Now we just want y isolated. Y doesn't have to be on the left-hand side, but we want y isolated. So we need to change this up a little bit. Some people are going to try to do the most and try to put y on the left. But again, you don't have to do that. You just need y by itself. So what can we do to this equation to get y by itself?
Subtract 3.
Subtract 3. So 2x is less than y plus 3. I could just get rid of the 3. So I would subtract both sides by 3. Thank you, Alexa. So 2x minus 3 is less than y. But when I read this, I have to read it from the y side. So even though y is not on the left-hand side, I don't need to do all that because it's going to still give me the same thing, but I need to read it in the y direction. So this is saying y is everything greater than 2x minus 3. So I have to read it in the y direction. So the y is greater than, the greater than part is facing y, the bigger part of the inequality. So that tells me, this is telling me to shade above, and this will be a dashed line. For the sake of the people who don't understand why, if this is the less than sign, some of you are like, wait, I don't get it now. I thought this was supposed to be less than shaded below. So I'm going to show you. Let's say if I subtract y from both sides, that would get me 2x minus y is less than 3. Then subtract 2x from both sides. That'll give me negative y is less than 3 minus 2x. I don't want negative 1y, so I'm gonna divide by negative 1 on both sides. That will give me y, because I'm dividing by negative, it flips my inequality and gives me negative 3 plus 2x. Same thing, y is greater than negative 3 plus 2x. This gives me a y-intercept of negative 3, a slope of positive 2, and this is y is greater than. So just read it from the side of y. So that's why it's going to be shaded above in the dashed line. So for the sake of your time, I'll just graph this quickly. Y-intercept of negative 3, slope of positive 2 over 1. It's going to be a dashed line. And I'm shading above. So this is what my graph will look like. Okay, any questions about that one?
Nope.
All right, this is the last one. So does this look like we want it to look?
Ms. Patterson,
Yes, sir.
Jada has something to say.
Could you go back?
Go back.
I want to take a picture of it.
Okay.
Okay.
So what do we need to do to this equation, guys?
We need to get
We need to what?
Get the Y.
So we want to isolate y. So what can we do to isolate y?
Subtract 3 again.
I just need to get rid of this plus 3. That's the only thing I need to do. So this will be a y only side. It'll be isolating. So I'm going to subtract 3 from both sides. So that'll give me y is less than x minus 3. The less than symbol tells me it's a dashed line. And less than tells me I'm shading below. So again, because I know the activity is going to take a while, we're going to go ahead and just I'm going to graph this quickly. Y-intercept of negative 3, slope of 1 over 1. Line. And I'm shading below. Awesome.